Hello and welcome to a video lesson on what would be our in-class lesson, Evaluating Trig Expressions Part 2. Last time we were in class, we were talking about using the unit circle to actually evaluate sine, cosine, tangent, secant, cosecant, cotangent, given a specific t value. Today we're going to continue that with a little bit more pieces to it. So just to warm us up, first one off the bat, we have sine of negative pi over 4. And we know that this is going to be in quadrant 4. And since it is in the pi over 4 family, it's going to be some version of root 2 over 2. And since we're in quadrant 4, it has to be a negative. So this one's pretty straightforward. It lands on the unit circle. It's in the pi over 4 family, quadrant 4. That gives us everything we need to know. But we have something like this, which does not land on the unit circle, cosine of 3 pi over 5. And in this particular case, it's kind of like when we did, like in geometry, you would do something like sine of 31 degrees. All you would do is plug this into your calculator and evaluate it. The same thing's going to happen here, except, well, we still need a calculator, but we have something that we need to do. Because we are working with 3 pi over 5, this is a radian value, so we actually need to change our mode into radians. Okay, and if you remember, we always told you you should be in degrees. Now is the time to switch it, and we could actually be in radians to actually evaluate this, because this value is given in radians, or this rotation. So let's go ahead and do that. Let me undo that. And we're in radians. And we can actually evaluate this. So here we have cosine of 3 times pi divided by 5. And here we get negative 3.09. I'm going to put an approximate negative 0.31. And logically, this should make sense because 3 pi over 5, or 3/5, is a little bit more than a quarter turn. So we are going to be in the negatives. And if you remember, the farthest left we could go is -1. The farthest right we could go is a +1. So it does land within that particular range. And it is close to the y-axis, so it should be relatively close to 0. So this makes sense. We should be able to follow that logic, at the very least, to make sure our signs are correct and our number should be relatively correct. Okay. Tangent of 1.56 can also be done on your calculator. Once again, this is a radian value, okay, because it's not in degrees, so it's a number, and we could actually evaluate it. Now, 1.56 is as close to the y-axis, positive y-axis, as you possibly could get, which means, well, it means a couple things. It means that the y value over the x value is going to be large over something small. Because if I try to make this triangle, right, I'm not going very far left to right, so it is small. But I am going really high up, and this ratio is going to be a really big one. And you're going to find this out later, but when it comes to tangent, you could actually go all the way up to, the ratio can go all the way up to infinity. So if I plug this in my calculator, all I have to do is tangent. Not inverse. I need to do tangent of just 1.56 because we're still in radians, so we're good to go. And the answer is going to be 92.62, approximately. Make sure you put that approximate symbol, or else it is going to look like it's an exact answer, and that's not fully correct. Okay? So that is how you work with things that are not specifically on the unit circle, and it is given in radians. Now, we should also know how to compare trig expressions. Instead of the 3 possible answers, there's a 4th answer that is now possible, and ironically enough, it is not possible. And you'll see what I mean. All we have to do is determine what sign goes in between, unless it is something like undefined. Okay? Well, that's supposed to be equal, not congruent. Now, cosine of pi over 3, we know is in quadrant 1. This is going to be 1/2. So we need to evaluate, right? Cosine of 5 pi over 6 is in quadrant 2. And ironically enough, this is still 1/2. So these are actually equal to each other. Sine of 3 pi, so that's it. All you have to do is find the value, evaluate it as needed, and then compare the values. Sine of 3 pi over 2, -1. Sine of 5 pi over 4, 5 pi over 4 is in quadrant 3. And that is also, well, that's not also, I'm sorry, it's two negatives, which make a positive. That's a positive one. A positive is always bigger than a negative, so it is less than. Cosine of 7 pi over 6, we know that this is going to be in quadrant 3. So cosine value, well, it's in quadrant 3, so it's going to be negative no matter what. It isn't the pi over 6 family, so we have root 3 over 2. Okay? And then sine of negative pi over 4 is going to be in quadrant 4. And this is going to be, ooh, sorry, I forgot to put the negative here. Negative root 2 over 2. Okay? And then this is a little bit tricky just because we're working with which one's greater or less than. And conceptually, root 3 is bigger than root 2. Okay? But these are negatives. So this is actually now smaller than root 2 because it's further away from 0. And it's almost negligible that we're dividing by 2 because it's just going to, it's dividing by the same value. If you don't believe me, we could always plug this into our calculator, figure this out. For instance, negative square root 3 divided by 2. And then negative square root 2 divided by 2. You could see that that negative 8.6 is further away from 0. So this one is the greater one. Okay? That's going to bother me. All right, let's keep going. A little more conceptual now. Cosine of 9 pi over 10. 9 pi over 10 is really close to 10 pi over 10, which is equal to just pi. So that means we have a rotation that's like this. Since we're working with cosine, we're looking at how far left we are going. And as you know, the farthest left we could go is -1. So we have a very small value. Okay? 4 pi over 9 is almost that quarter turn. And you could, as you know, in quadrants 1 and 2, sine is positive. So right away, this is going to be a negative. This one's going to be a positive. And right away, we could say, okay, positives are always going to be greater than negatives. So conceptually, can you understand where it's landing and use the signs appropriately? This one's a little more obvious because I'm just using positives and negatives. But you should understand, okay, this is a small negative number. A small number. It's actually probably one of the furthest away from 0 you could get in the unit circle. Cotangent of 7 pi over 4 is like asking tangent of 7 pi over 4 and then taking the reciprocal to it. So here, tangent of 7 pi over 4 is root 2 over 2. So we take the reciprocal of this, 2 over root 2, and then multiply by root 2 over root 2. And we get 2 root 2 over 2, which is just equal to root 2. Okay? And then cosecant of negative pi over 6 is going to be equal to, well, cosine is the reciprocal to sine, or cosecant is reciprocal to sine. And then the rotation is going, so let's just write it out. We're working with the pi over 6 family, and we're in quadrant 4. So this is going to be equal to a negative 1/2. Take the reciprocal to this, which is a negative 2. We have a negative compared with a positive. Oh, this is a negative, I'm sorry. Cosine of negative 7 pi over 4. Okay. Square root of 2, if you don't know, is approximately 1.4. Since this is negative 2, this is going to be the smaller number. So you put the greater than symbol. okay? All right, secant. Secant of 3 pi over 2. Secant is the reciprocal of cosine of 3 pi over cosine, and ironically enough, we have cosine of 3 pi over 2. So if we actually evaluated this one, we'll get 0. And what's the reciprocal to 0? Well, that's 1 over 0. This is undefined, so this is actually not possible. That's where the NP kicks in. Okay? So if it's undefined, you can't compare the values. It is not possible. Moving forward, find all the t values such that t is between 0 and 2 pi, including 0. Okay? So technically, there should be 2 answers for these problems because we're looking at this particular window. Okay? So cosine of t is equal to 1/2. Well, cosine is positive in quadrants 1 and 4. So somewhere here. And since it's equal to 1/2, that is in the pi over 3 family. So t has to be equal to, at the very least, pi over 3. And the pi over 3 equivalent in quadrant 4 is going to be 5 pi over 3. Both of these land between 0 and 2 pi. So we're good to go there. Okay? Whereas secant of t undefined? Well, we need to know the reciprocal to this, which is cosine of t. And reciprocal to undefined is 0. Okay? Where's cosine equal to 0? That occurs in 2 spots. Your y-axis. So t has to be equal to pi over 2 and 3 pi over 2. Okay? And then moving to our last one. Tangent of t is equal to negative root 3 over 3. Tangent is negative in quadrants 2 and 4. And if you remember my little trick on this, how many 3's do we have? We have 2. So that's going to be in the pi over 6 family. And we're looking in quadrants 2, which means this is 5 pi over 6. So t is equal to 5 pi over 6. And in quadrant 4, it would be 11 pi over 6. And we're done for those. Now the last one is something kind of new. It's you probably did this, you might have done this in geometry with the exception of these 6 trig functions, but it is still doable. So if sine of t is equal to 1/8, where t is in quadrant 2, solve for all 6 trig functions. I only wrote out the 3 because those are the 3 main ones we talk about, but we could actually illustrate this in the unit circle, right? If I actually draw this out, we're in quadrant 2. That means we are working with something like this. We always draw it as if it's a reference angle going to the x-axis. And sine of t is the y term, right? So I'm going to put a 1/8 here. And we could actually evaluate this from here. We don't know what this is. I'm going to put an x here. But since we know what sine of t is, we could actually just write here is equal to 1/8. Okay? And we could actually fill this in as well, cosecant of t. And we could do secant of t, just the right amount, and cotangent of t. Okay. Now, since sine of t is equal to 1/8, cosecant of t would have to be the reciprocal to it, which is just 8. Okay? We're in quadrant 2, so that means your x value has to be negative. And our unit circle equation is going to kick in. Okay? Sine is technically equal to y. So if we consider that, and here we have our circle anyway, so we could do x squared plus y squared is equal to 1. Or if we know sine is equal to y, there's going to be a trig equation that's involved with this, or trig identity. Since x is cosine and y is sine, we could actually write this the unit circle equation as cosine squared of t plus sine squared of t is equal to 1. And then this where substitution kicks in. Okay? All right. So we could either redraw it like this and turn it into a triangle, or we could use this particular identity and do the Pythagorean theorem with trig functions in it. For the sake of simplicity, I'm going to do it here. 1/8 squared is equal to 1, and then I forgot, sorry, x squared plus 1/8 squared. 1/8 squared is going to be 1 over 64 is equal to 1, and then drop the x squared in. Subtract the 1/64. We get x squared is equal to 63/64. Square root, square root. You should always have the plus or minus. And you get x is going to be equal to plus or minus, but since we know it's going to be negative already because I stated so, I'm just going to put the negative there. Square root is 63. Well, 9 goes into it. That's a perfect square. And 7, so we're going to have 3 root 7 in the numerator. Square root of 64 is 8. Okay, and now we have this particular value. We could throw this in here, which is equal to negative 3 root 7 over 8. And now we could write the rest of these ratios out. Cosine is the x value, so this is going to be equal to negative 3 root 7 over 8. And we're going to have to do some reciprocal work. If I took the reciprocal to this, because that's what secant is, it's going to be 8, negative 8 over 3 root 7. Multiply root 7 in the numerator and denominator. We end up getting 8 root 7 over 21. Because 3 times 7 is 21. Oh, the negative. So don't forget that. All right. So here, negative 8 root 7 over 21. Last but not least, tangent. Tangent is the ratio of the opposite over the adjacent, okay, or the y over the x. So doing that, the y is going to be 1/8. So I'm going to put tangent of t is equal to 1/8 all over negative 3 root 7 over 8. Nice part about this is when you multiply by the reciprocal, I'm going to have 1/8 multiplied with 8 over, let's drop the negative in the numerator, 3 root 7. 8s will cancel out. So you end up getting negative 1 over 3 root 7. And then once again, you have to multiply by root 7 over root 7, which is going to be equal to negative root 7 over 21 again. Okay? So there's your tangent. Negative root 7 over 21. Take the reciprocal to this, which is actually much easier if you do this version of it. If I took the reciprocal to this, this would be 3 root 7, the negative 3 root 7. Because I'm going to undo this really. If you don't believe me, take this, do the reciprocal of it, and see if it equals that. Okay? And let's drop this in, negative 3 root 7. We're done. All 6 trig functions are done. So that completes trig expressions. Okay, we have some new ways, some fancier ways to evaluate some of these problems. We have some more conceptual understanding problems, and then we can now solve for t, and then and solve for the 6 trig functions given one specific trig value. Okay, so if you do have any questions, bring them to class, and I will see you in the next one. Bye.